Hi, I am Sikandar Rafiq and you are watching the software development learning channel DevCom Learn Software Development. In this channel we are going to create the different video series for different computer science topics, including but not limited to object oriented programming, C++, Qt, C++, Android, backend development with Node.js, backend development with Elixir or Phoenix, and Java, JavaScript and many more. Today we are going to create the video series for DBMS crash course with Postgres database. Postgres database is the industry standard for backend development. So it's a very strong and powerful backend database. If you feel database concepts confusing, especially normalization, entity relationships, and functional dependency, and primary keys, foreign keys, and relationships. So this video series is for you. We will discuss all these concepts in a very simple and intuitive way. So let's deep dive into the course. Okay, today we are going to start with what is the database and how we are using in this software development. Before going to start our actual course, here is a brief introduction with the presenter. As you know, my name is Sikandar Rafiq and I have more than 25 years of software development experience. My expert areas are desktop application, DBMS with Postgres and many other database, object-oriented programming, C++, CLI, Qt, C++ and QML, Java, JavaScript, Elixir, Phoenix, and Angular, Node.js, Express, REST APIs, and MongoDB, Scrum, Agile development, system design, C#, AWS integration and payment gateways integration, and many more. Okay, let's start with the actual course. What is the database? Database is the organized collection of data stored electronically so that it can be easily used to store the whole information and search, update and manage. So we will discuss, for example, this is the application and different users, for example n to n number of users are using this application. So here you can see, here is the database. So all the information we are storing into this in database. So maybe we are saving the information for the hundred of thousands of users. So all information we are saving here in the database, and after that we are searching with information with the SQL queries by different clauses, where clause, order by search, and many different criteria according to our business needs. We can update that information with the update commands, SQL commands, and we are managing the whole database. So this is the database is the hub where we are storing all the information for our system. Maybe it is a banking system or the school system, etc. So a very simple database example is the school system. So in the school system we are storing the information, student record, teachers information, courses, attendance and results, and maybe some other information as well. Another database example is the banking system. So banking system, we are saving the information, client's information and its account information, account history, transaction information, and etc. some. So almost all these software are now using the databases, any type of database, maybe it's DBMS database or RDBMS database or NoSQL database. We will discuss these terms in more detail in the next topics, next videos. Okay, database has some distinct features. So scalability, first is scalability means database can access by the large number of users. So as okay. So you can see if this is the information, this is the application. Maybe it is a web application or desktop application. So it saves all the information to its database, and large number of users, maybe thousands of users are using this. So this is called the scalability, right? The second database feature is the data integrity. Data integrity means accuracy, using the data should be valid and accurate. So we will discuss all the data integrity constraint types in more detail in this next video. So next one is the security. So security means we are accessing the database with certain rules and access and permissions. So for this we are using the two terms. First one is called authentication. Authentication means the user is use the credentials, username and passwords. Credentials. So each username has username and password. So by using the credential, user will log into the application, and through the application it is manipulating this database. And the second one term is which is used is authorization. What is authorization? Authorization is certain user had certain rights. So if user has some rights, so it can do some operations, otherwise it cannot do the operations. For example, in our application we have the normal user, and then admin user. So for example, normal user can just view the media files. For example, we are taking any example of the application media player, right? So normal user can view the media files, video, audio and images, etc. But it cannot upload. So admin user can upload the videos, So this is the right which is only given to the admin user, right? So no normal user can upload the video. So any other task, any other right which can be controlled using the role-based authority. So this is the concept against the authorization. If user is authorized to perform a task, so it can do, otherwise it cannot be allowed to perform such tasks. So this is the authorization. So all this covered under the security hub. Then there is a data consistency. Data consistency means data should be synchronized and logically ordered and correct. For example, if there is a banking system, so we take another advantage example. So user 1 account, for example, user 1 account has the $1,000 and the user 2 account has $500 in his account, right? So if we perform the operation, transfer money $200 to account 1 from user account 1 to user account 2. So there is the two steps, right? One is the detecting the $200 from here, so it should be $800, and the second task is adding here, so resultant is should be $700, right? So this is the whole transaction. If first task is done and $200 is deducted from the account 1 here, but it is not due to certain error, application error, it is not added here, and it is still remains the $500. So this is called the data inconsistency, right? So data should be consistent. If there is some error in this transaction, so whole the transaction should be rolled back. So user 1 account should be remain to previous balance $1,000, right? So this is the data consistency. Right? So data should be consistent and accurate, logically accurate. Analytics. So different databases user can and the company management can use for better decisions. For example, if there is some e-commerce shop and user can track what is the month in which we are getting the maximum sale. So this can be easily predicted through the stats shown by the database or some other information in which period of time or which at what event, at any festival or an event, we are getting more sales. For example, Thanksgiving Day or some other event. So these type of stats, database stats can analyze and leadership can make the good decisions beneficial for the whole organization. So this is the analytics. So database can be used for analytics and for better decision making. Okay, let's go deep dive into the data integrity. First type of data integrity is entity integrity. So what is entity integrity? Entity integrity is, we have for example, user table, users table, user ID, and the name and some other attribute, address and phone numbers. Okay, so first one is this is we make it the primary key, right? Let's call it the primary key. We will discuss the primary key in more detail in the next videos. So first rule is it cannot be null. So database ensure it cannot be null, right? It has certain values. For example, in the Postgres, so if you make the type to serial or big serial, so this is the types we will detail discuss in the next videos. So database is automatically adding these numbers, right, from 1 to the upward till maximum level of this. For example, 101 is assigned to user Ahmed. So second entity integrity, it cannot be assigned to any other number. It cannot be assigned to Zia. So this is the unique numbers, right? This is invalid in the database. So only user 101 is assigned to Ahmed, right? It cannot be assigned to any other person. Then there is a differential integrity. Okay, we will see what is the differential integrity is. If we go to the backend page, okay, this is the user table, and if we create another table, for example the payments table, so first one is ID, this is the primary key, and the next one is payment month, for example payment month, and the next column is amount, and here we are using the user ID as a foreign key. Here, for example, ID is 1 and payment month is March, amount is for example $100, and user ID is 101, right? So payments table will create the details of the each month payment. In some case, if this user is deleted and somehow, so then this record is invalid now. It makes no sense. It should be deleted from the, this is called the child table. User table is the parent table. It is called the parent table, and this is called the child table, right? So this record should be deleted now. So this is the differential integrity errors. If it is not deleted, this makes no sense, because in the database we have no user with the record of the 101, right? So this is the differential integrities. We will discuss in more detail in the next topics as well. Domain integrity. Domain integrity means, so data should be remains within the range. For example, if we have some name is the field, table column, right? So it should be, we specify the rule, it should be more than 5 characters, right? It cannot be less than 5 characters. So allowing the name ABC or 4 characters, less than 5 characters, is not allowed. The second example is the email address. So it should be in the proper format. Right? So this is the domain integrity. If it is not ensured, then we have the problem. So database make sure, so domain, there is no errors regarding the domain integrity as well. User defined integrity. So we can define some business rules. For example, we can define the business rules for salary. Salary is our column type, and it cannot be negative numbers. We cannot specify the salary is minus 1000. This is illogical, so it should be positive numbers. So this is the types of data integrity. We have discussed primary key should not be null and each row must be unique, right? So we have discussed all these integrity with the examples. How database maintain the data integrity. We have seen the primary keys. Database use the primary keys and foreign keys to maintain the data integrity, and there is the constraints. The example we are using for the name not less than the 5 characters is the constraint. So we will apply some constraint on the different types. For example, the email should be in the proper format, and some other constraints as well. As we move further, we will discuss in more details. Transactions. We have discussed the one transaction where the $200 is debited from one account to the another account. So database maintains the data consistency and integrity. So whether the whole transaction is succeeded or whether it should be rolled out, it should not be committed. Validation rules. It is just like same as the constraints. So we can apply some validation rules, just like this salary should not be negative or any other constraints, just like this. Okay, data consistency we have already discussed. Okay, what is the database table? Okay, data stored in the structured format is called the table. Table is made up of columns and rows. So this is the another example. For example, this is the table. Here first column is student ID. So this is the primary key. Then we have the name and the department and phone number and address. So this is the whole is the data, right? And these are called the columns. If we yes. So these are the whole or the columns or fields, right? This is the data. For example, 2, it should be any other number, and just amount and etc. So all these are data, and we call it, this is the whole is the one row, right? This is the second row, and all rows are the data, contains the data, and these are the columns. So vertical lines are columns and the horizontal lines are the rows, right? So here you can see, so these are the primary key, roll number, and all these are columns, roll number, name, CGPA, these are the columns, right? And these are the rows or tuples. So these, we have 4 rows in this table, and the whole this structure is called the table. So in this table we are storing the student record, student data, right? Okay, so real life analogy is, you can think of the school register. So table is basically a register. So you can see there are vertical lines which are column, name, roll number and class number, and the row is each student comes in and add its detail. For example, entering daily attendance sheet, you can say. So each row is the one row representing the one row, and then there is the columns in the tables. Okay, components of the database. Okay, there are several components, critical components we will discuss, which the database is comprises of. The first one is data. So actually the data information we have discussed, all the data we are saving is the actual data. Here you can see in the users table, these are the data and these are the data, user table and the payments table. So all the data it contains we are saving in a database. Okay, what is the schema? Schema is the, I will show you. When we create the users table, for example, users table, we are creating the different columns as well. For example, student ID underscore ID is of type, for example, integer, and the name is of type characters 30, and the address characters, for example 50 characters, and then the phone numbers, maybe this is also the character with the 20 characters. So all these types of we have called it schema, right? So what it is doing, it is defining what is the blueprint of the our users table. So columns, which columns table users table contain, and column type, data types we are defining. Then we have some other parameter as well, whether it is the null is equal to true or false, right? So we can specify some other properties as well, and the default values as well. So all these comes under the schema. So when we are creating the table, what we are doing, we are basically defining the schema of any that table as well. Schema also contains the relationship between the different tables. For example, users table has relationships with the payments table. Through foreign key, right? Right. So all these table information, table schema, and the relationships, all these contains in the schema, excluding the data, right? DBMS is a software database management system that manage the data operations like storage, retrieval, and security. So there are different types of database management systems: Postgres, Oracle, MySQL, and SQL Server. So we will in detail the Postgre database and work in this Postgre database management system, right? So DBMS management system is different, two types of software we will discuss: queries and instructions. So there are SQL queries we will use to retrieve and manipulate the data within the database. We can insert the data through these SQL queries. We can SQL queries, we will insert the data and then we will delete the data. We will update the data. We will search or fetch the data. Right? So we will manipulate by using the SQL queries. We will see in more detail how we are using the SQL queries. Users. So actually user is the people or the system. So in the example, first example I will show you the application or the user. This is the app. So it is using the database. So these are the application or the users, right? Then it is using this database. So these are the components of the database. Okay, different type of database. So first one is the RDBMS. RDBMS is the organized data into tables made of rows and columns. So we will discuss in more detail in the next video what is the RDBMS. RDBMS says because it has the relationships between the table. So one table is affiliated with the other table, and just like we have seen here. Maybe we have deleted for example, the users table is linked to the users table is linked to the payments table and some other information as well. We have the orders table, then we have the order detail table, order items, for example. So all these tables are in somehow have relationship with each and other. So this is called the relational database management system, right? So there is another type of database which is called the NoSQL. So NoSQL is designed to handle the structured, unstructured data or semi-structured data. RDBMS is used to handle the structured data because we are creating the structure here. You have seen we are creating proper structure in the tables. Yeah, here you can see the proper structure: roll number, student name, department, phone number, and address. So we are first create this structure which is called the schema, and then we are adding the data into it. So RDBMS is proper structured data for storing the structured data, but NoSQL is for saving the unstructured data, just like text, images, videos, and sensor data, etc. So thank you so much for watching this video. In the next video we will discuss what is DBMS, database management system, and RDBMS. So I hope you enjoy the work. So please subscribe, share and subscribe the channel. so that you can get the next video whenever I posted it. Thank you so much for watching the video.